So guys, what we're doing today is starting our last unit, Unit 4, on conic sections. People ask, is this hard, easy? It's probably one of the more detailed things we're going to do, okay? Lots of little details. If we had covered this back in October, you would have shot me. But this point, you've done a lot. You've learned a lot. You're probably better able to handle some of the things we have. So when we say conic section, conic comes from the word what? Cone. Okay, so this is a cone. What does it mean to section something? Okay. If you were to go straight across the top, that conic section produces a circle. Okay, so this is what it means by conic section. So the first one we'll study will be a circle, and that comes just by going horizontally across the top of the cone. Now, if I were to go at an angle, that produces a what? Oval or an ellipse. Okay, that's our second conic section. Okay, and then one that we learned last semester that will come back. What is that? Parabola. Okay, so if you section the cone like this at an angle, okay, and let's see if I can get this back together, then you create a parabola. And then the one you haven't seen, if I just go straight off the top of the cone, or the side of the cone like that, it looks like a parabola, but it's a little bit different shape. This one is a hyperbola, okay, and we'll get to that one. So that's what we mean by conic sections, okay? So it's a different section. Depending on where you slice the cone, you get something different. So, if you slice lower, you get a bigger circle, so there it is. So you guys can pass that around for the object lesson. So, there are four types of conic sections we just talked about here that would do circles, ellipses, parabolas, and hyperbolas. Now, why are these important in mathematics? These are used to model a lot of things that you see every day. So, for example, this is a parabola. So, like something like that, the path of that ball was a parabolic. Okay, so we can model that shooting a basketball. If you watched that last night, those are parabolas. I doubt that the people that were doing it were thinking, is the parabola open up or down? Where's the vertex? Yeah. So we've got the ball coming back. There we go. So that's the path of a parabolic path or a parabola. Other things, the ellipse. If you go take astronomy, if you talk about how we rotate around the sun, most of your planets do an elliptical orbit. We think of them as going a circle going around the sun, but actually it's not a circle, it's an elliptical orbit. And then one that you don't know that we'll get into more is an hyperbola. The example of that in nature is when you have a sundial that's outside and the sun is shining on it and the shadow that it casts. That's a parabola, hyperbolic curve, okay? So, before we get into those, we need to do something algebraically, a skill that you've got to have solid between now and the end of the year with every one of these conic sections. Let me just take a little break. What we need to do today, there's an algebraic skill that we're going to need in solving for each of these conic sections called completing the square. And so where this comes from, let's take a look at this. X minus 2 squared. Please don't tell me this is x squared minus 4. Do you agree? It's not x squared minus 4, right? How do I figure out what x minus 2 is? Yeah, it's x minus 2 times x minus 2, which is x squared minus 4x plus 4, okay? What we will say is that this is a perfect square trinomial because that trinomial can be written as something squared. How do I know that? If I were to factor this, I would be looking for what? If I were to factor this, I would be looking for two numbers that do what? Yeah, multiply to 4 and add to negative 4. What numbers can multiply to 4 and add to negative 4? Negative 2 and negative 2. So that means this is x minus 2 times x minus 2. Another way of writing that is x minus 2 squared. That's why this is a perfect square trinomial, because I can write this as something squared, okay? Now, when we were back in the fall solving quadratics, what was one of the methods we could use to solve a quadratic? Not completing the square, but taking square roots of both sides, okay? So if I can get a perfect square, that helps me take the square root of both sides, okay? X plus 4 squared, okay, that is x plus 4 times x plus 4, which is just x squared plus 8x plus 16. What we're trying to get to a skill where if you see something like this in the wild, you can recognize that's a perfect square. What two numbers multiply to 16 and add to 8? 4 and 4. So this is x plus 4 squared. It's sort of trivial here because I started out with the answer, I changed it, and then I gave you back the answer. But we want the skill of being able to take things like this and create or recognize when they're a perfect square. So let's talk about 3 different ways we've looked at solving things. Solving by factoring, okay? So if I look at this, can I factor this whole expression, okay? So let me look at it. If I want to solve something by factoring, usually I set it equal to what? 0. So that would mean I would subtract 25 from both sides. So I get x squared plus 8x minus 9 equals 0. Okay, if that factors, there are two numbers that do what? Yeah, multiply to negative 9 and add to 8. Are there numbers that multiply to negative 9 and add to positive 8? Yeah, 9. Yeah, 9 and negative 1. So this means that x plus 9 times x minus 1 equals 0. Therefore, x is equal to what? Yeah, negative 9 and 1. Okay, there's my solution. Okay, so that's one way of solving an equation that looks like this. Another way of solving, and many of you showed allergies to this on the test, was the quadratic formula. Okay, so you need to figure out how to get over this. Again, with quadratic formula, it is for something set equal to 0. So x squared plus 8x minus 9 equals 0. This means that x equals a negative of 8 plus or minus the square root of 8 squared minus 4 times negative 9 over 2. This is no longer algebra, this is arithmetic. Okay, x equal negative 8 plus or minus the square root of 64 plus 36 over 2. What is 64 plus 36? 100. X equal negative 8 plus or minus the square root of 100 over 2. That is negative 8 plus or minus 10 over 2. What is negative 8 plus 10? 2. What's 2 over 2? 1. What is negative 8 minus 10? Negative 18. Negative 18 over 2? Negative 9. Am I shocked that these are the same numbers? No, they need to be the same number, okay? Now, how would perfect squares come into play? Okay, look at the left side of this equation. Are there two numbers that multiply to 16 and add to 8? 4 and 4. So this can be written as x plus 4 times x plus 4 equal 25, or x plus 4 what? Squared equal 25. Now I can take what of both sides? Square root. So if I take the square root of both sides, there's one thing you have to remember, which is what? X plus 4 equal, what's the next thing I write? Plus or minus square root of 25. So that's 5. Okay. So when I take the square root of both sides, I get x plus 4 equal the plus or minus square root of 25. Therefore, x equal negative 4 plus or minus 5. What's negative 4 plus 5? 1. What's negative 4 minus 5? Negative 9. Okay. So these are all just 3 different ways algebraically we could solve a quadratic. We're going to work on the one you see there in purple on the third column, using perfect squares to solve quadratics. Now, which of these is your least favorite? The one in the middle, okay? So you can use completing the square instead of a quadratic formula. So you'll see that as we go forward here. So if we can recognize, the key here was recognizing that was a perfect square. That was x plus 4 squared. So I can either recognize it as a perfect square, or maybe I can turn it into a perfect square. That's what we're going to spend today's lesson doing. So real quick, let's take an aside and let's do something. Let's look at something like x squared plus 6x. I want to figure out what would make that a perfect square. X squared plus 6x plus whatever. So let's take a look at this. So let's visualize it. This is x squared, okay? So what I've got a square that is x by x, okay? So this is x squared, and then how many x's? It's x squared plus what? X squared plus how many? 6 x's, do you see that? So x squared plus 6x, here's 1, here's 2, here's 3. How many more do I need? Okay. So this one I'm going to turn around this way and pretend like that is perfectly straight. So again, you're pretending these are all perfectly lined up. Okay, I can do a little bit better on that one. There we go. Okay. Now, look at this. Is this shape a perfect square? What would it take to make this a perfect square? I need to fill in what? So I would need something like this. I would need one of these. Not only one, I would need several of these, right? How many of these would I need? 9. And again, you're pretending that this is all perfectly positioned. Now, is that a perfect square? Okay, that's a perfect square. So this is x by x, okay? And this is what, 1 by 1? So what's the distance from here to here? This is x plus how many? This is x plus 3. What is this? This is x plus 3, okay? So it looks like this square is x plus 3 times x plus 3, right? Okay, so what would x plus 3 squared, what would that look like? That's x plus 3 times x plus 3, which is x squared plus 6x plus 9. So it's going to take a 9. A 9 is the only number that makes that a perfect square. Okay? So that's where the perfect square concept comes from, is that if you're to truly look at this, this is a perfect square. Okay? What if instead of x squared plus 6x, what if it was x squared plus 4x? Okay? What would make it a perfect square? So so this is x plus 2 squared, which would be x squared plus 4x plus 4. See, this is x squared plus 1, 2, 3, 4x plus 4. X squared plus 4x plus 4. Another way of thinking that is x plus 2 times x plus 2. Okay? So that's what makes this a perfect square. Now, when you look at something like this, to make it a perfect square means that I've got two numbers that multiply to this and add to this. But instead of two numbers, what do I really have? I don't have two numbers. I've got what? One number, because it's a perfect square. So I'm saying, is there a number that when I square it, I get this, and when I add it to itself, I get this? So think of a number like 12. What number do you add to itself to get 12? 24, 12, 22, 11, 10, What are you doing? Every time, what are you doing? Yeah, but you're taking from the number I'm spitting out, you're giving me what back? Half of that number. It's the only number you can add to itself and get another number. So you have to take half of the original number. So if the number is 100, half of 100 is 50. So 50 plus 50 equals 100. Okay. So the key skill is recognizing whatever that middle number is. You got to figure out what is half of that, and that's going to be the key to finding the perfect square. So in this case, if I want to figure out what would make that a perfect square, okay, what number can add to 12? The number adds to itself to give you 12. Yeah, so if this number's add to give me 12, and they multiply to give me c squared, what number is it? So that's going to be what, 6? So this one's going to be 36, okay? And then the number c is going to have to be, what, half of that, which is 6, okay? So let's just do an example. So x squared plus 12x plus 36, that's going to be x plus 6 squared. So what you do, whatever half this number is, so whatever that number squared is, that's the number that has to be there for this to be a perfect square. 6 can multiply by itself and give you 36. 6 can add to itself and give you 12. Okay. So what I'm going to do, a lot of times when I complete the square, I'm going to take half this number and I'm going to write it as 6 squared is what I'm adding. That way it's easier to do the factorization that follows. So we'll do another couple of examples. In this one, okay, x squared plus 8x. Okay. What number can you add to itself and get an 8? 4. Okay. So in order to complete the square, I have to have, this has to be 4 squared. Because 4 squared is what? 16. So 4 times 4 is 16. 4 plus 4 is 8. So this is, you factor this as x plus 4 squared. Okay. Or the other way of thinking, what two numbers multiply to 16 and add to 8? That's 4 and 4. That's x plus 4 times x plus 4. You do this long enough and you just jump to, well, that's x plus 4 squared. You don't have to do it. You can write it as 16. You'll see later why I do that. Okay, just it's easier to go from this step to this step if I just have the 4 there. So here's what you need to know. When you've got x squared plus bx plus c, and you want to complete the square or make this a perfect square trinomial, then what you have to figure out is what is half of this number b, okay? And then you have to square that. So when you take this number half of it and you square it, that's the number you have to add to make this a perfect square. So let's look at this example. I want to solve the equation by completing the square. The first step is just to move that constant to the other side. Okay, does everyone agree with that? Now, x squared plus 10x, what's half of 10? 5. So in order to make this a perfect square, I need to add 5 squared to both sides of the equation. You can't just change one side of the equation. Okay? So what two numbers multiply to give you 5 squared and add to give you 10? What numbers do that? What's 5 squared? No. So what numbers multiply to 25 and add to 10? 5 and 5. So I'm saying what numbers, but it's what number. What one number can you multiply by itself and get a 25, add to itself and get a 10? That's 5. So to factor this, this is x, write down that plus, and here's the reason I write 5 squared. Then I just write down 5. Okay, that's what the left side is now. So x squared plus 10x plus 25, or 5 squared, that is a perfect square. So x plus 5 squared equal, what's 25 minus 7? Let's go with 18, right? Now, how do I solve this? I take the what? Square root of both sides, okay? So in this case, so if I take the square root of both sides, so I get x plus 5 equal, what do I write next? Plus or minus, something we did last semester. Let's write 18 as 2 times 9. Why did I do that? Yeah, so this is x plus 5 equal plus or minus 3 square root of 2. So x equal negative 5 plus or minus 3 square root of 2. Okay? So all I did was I completed the square on one side so that I could get a perfect square so that I could solve using square roots. Okay? When you saw this last fall, it had squares, and that was your clue to use taking square roots of both sides. But you can take any trinomial, complete the square, and then use square roots. So this is an option that some people like this better. I prefer it to the quadratic formula. But you get answers like this sort of looks like a quadratic formula kind of answer. Okay, but you can solve any quadratic by using completing the square. So let's do a few more. So I want to solve this. First step is to move the constant where? To the other side. So this is x squared plus 5x equal minus 9 over 4. Now, in order to complete the square, I need to look at that 5 and figure out what number adds to itself and gives you a 5. Come on, there is one. Yeah. It's 2.5. It's 5. You take half of 5. Okay. So what I'm going to do, I'm going to add 5 halves squared. Okay. That's how I complete the square. Take half of that number 5, which is called 5 halves, and square it. If I add 5 halves squared to the left side of the equation, what must I do to the right side? I got to add the same thing. Now, the reason I write it as 5 halves squared is now this is guaranteed to be a perfect square, okay? Because 5 halves times 5 halves is 5 halves squared. 5 halves plus 5 halves is 10 halves, or 5. So this is x what? Plus, come on, what is it? X plus 5 halves squared, okay? What number multiplies by itself to give you 5 halves squared? Well, that's 5 halves. What happens when you add 5 halves and 5 halves? You get 5, okay? So we constructed this so that it would be a perfect square. So to read your answer is just x plus 5 halves squared. And all of that equals negative 9 over 4 plus 25 over 4. What's 25 over 4 minus 9 over 4? 5 halves squared. That's 25 fourths. So what's 25 fourths minus 9 fourths? This is where you would say 25 minus 9 is, come on guys, I'm not hearing it. 25 minus 9 is 16, okay? So this is x plus 5 halves squared equal 16 fourths. Okay? What can I do with 16 fourths? That's 4, okay? So this is x plus 5 halves squared equal 4. Now I can do what? Square root of both sides. So this is x plus 5 halves equal, what do I write next? Plus or minus. What's the square root of 4? 2. Okay. So x equal negative 5 halves plus or minus 2. And to simplify that, x equal negative 5 halves plus or minus, instead of 2, let's just call it 4 halves. Why did I do that? Yeah, so common denominator. So what is negative 5 plus 4? Yeah, so I get negative 1/2. What is negative 5 minus 4? Yeah, so minus 9 halves. Okay, so your answer is negative 1/2 and negative 9 halves. Okay, so the key to completing the square is whatever this x coefficient is. Figure out what half that number is. What kind of numbers do you love to see there? Do you like odd numbers or even numbers? Even numbers, because what? No fractions. You get an odd number there, you're going to have a fraction, just like we did, but you can handle it. We just covered a whole unit of fractions. If that had been a 6, what's half of 6? 3. So you're going to add 3 squared to both sides. That's what people like better than seeing a 5 there. Okay? So this one, what do I do first? Yeah, move the 2 to the other side. So x squared plus 18x equal negative 2. Okay? In order to complete the square, I look at that 18 and figure out what? What is half of it? What's half of 18? All right, so I'm going to add what? Add 9 squared. If I add it to the left, what must I do to the right? Same thing. So what do I have on the left? This is x plus 9. That's the whole point. That's why you're doing this, so that you will get a perfect square on the left. If you check it, 9 times 9 is 81. 9 plus 9 is 18. Okay. So x plus 9 squared equal, what is 81 minus 2? 79. Now what do I do? Square root of both sides. X plus 9 equal, plus or minus, square root of 79. So x equal negative 9 plus or minus square root of 79. Okay. Let's do, I need to do one just a little bit different. Let me just do one over here on the side. You can see one of the differences. We'll say x squared minus, so what do I need to do for this? Move the 1 to the other side, so x squared minus 12x equal negative 1. Okay, now, here's the deal. What's the number that's in front of x? What's the coefficient of x? X. Yeah, the coefficient of x is negative 12, okay? What's half of that? Negative 6. What is negative 6 times negative 6? Positive 36. Okay, can't you see that when I square a number, what do I always get? What kind of number do I always get when I square a number? Positive, okay? So the fact that there's a negative here doesn't really bother me. Just look at 12. What's half of 12? I mean, you can say what's half of negative 12, and you get negative 6. Negative 6 times negative 6 is 36. Or you can just say, let's forget the negative sign. What's half of 12? 6. What's 6 times 6? 36. So I'm going to add 6 squared to both sides of that equation. So now, are there numbers that multiply to 36 and add to negative 12? Not numbers. Is there a number that you can multiply it by itself and get 36 and add to itself and get negative 12? Negative 6. So this is x minus 6, okay? All the others, when you got to here, this was x plus 9. So when you have a minus sign here, this is always going to be a positive number, x minus 6. So this is x minus 6 what? Squared, okay? Equal, what's 36 minus 1? 35. Then you take the square root of both sides. X minus 6 equal plus or minus square root of 35, or x equals 6 plus or minus square root of 35. Okay. That's the only difference when you have a minus sign in front of the x term, is when you get your perfect square, you'll have a minus sign, but you're always adding a positive number when you're completing the square because you're adding a number times itself, which is always positive. Now let's look at this one. What's different about this one? Has a 3 in front. Now when we were factoring, it made a difference, right? Because this meant we had to factor by what? Grouping, okay? So 3x squared plus 12x. Let's go back to our algebra tiles. So let's clear this. So 3x, what did I do? So 3x squared. So how many squares do you think I have to complete here to get this one done? 3. Okay, I got 3x squareds here, okay. And then 3x squared, what was it, plus 12x? Is that what it was? Okay, so how many do you think each of these will get? I got 12, and I need to divide 12 up into how many pieces? 3. I got 3x squared plus 12x, okay? So I got to put the 12x's. Some of them go here, some of them go here, and some of them go here. How can I distribute 12x's evenly? Give each one of them 4, okay? So I can say this guy gets 4. This guy gets 4. And I wish they just had some that were already horizontal instead of making me do this. Okay, so this one got 4. So what we're going to do, I'm not going to do, but I would then give this one 4x's and then give this one 4x's. Okay, what's it going to take to complete the square here? How many ones? 4. So 1 there, 1 there, 1 there, 1 there. So I would need to redo this twice more. Okay, so this is x squared plus how many x's? Come on, count the green. X squared plus 4x plus 4. Another way of writing that, this is, what is the length from here to here? This is x plus 2. This is x plus 2. So this is x plus 2 squared. Did you see that? So this is x plus 2 squared. How many of those do I expect to see here? 3 of them, okay? So what this is, we'll check our answer in just a minute. So 3x squared plus 12x. And so what we said that this is going to end up being 3 times x plus 2 squared. It's going to look like that, 3 times x plus 2 squared, because if you look at this, 3x squared, I had 3x squared. I had 12x's. Put 4 of them here. I'm going to put 4 of them here and 4 of them here, okay? And then I'm going to have 4 ones to complete this. So this is going to be x plus 2 times x plus 2. So I'm going to have 3 x plus 2 squared. Now this gets a little bit more complicated. Once you've got you don't really need the visual, but we can have a method for doing this. Here's the thing you just need to keep in mind. Anytime you have a number other than 1 here, you're going to have to factor that number out. So let's write this as 3x squared plus 12x equal -7. Does everyone agree with that? I get yeses, okay? Now, what you need to do, if the leading coefficient is not 1, you have to factor it out. So this is 3x squared plus what? 4x, okay? And I'm just going to leave some space there. Now, how do I complete the square looking inside the parentheses? How would I complete the square here? What do I look for? What number? What's half of 4? 2. So I need to add what? 2 squared, okay? What's 2 squared? 4. So it looks like on the left side of the equation I added 4. But somebody tell me that what did I really do? This is where people make a mistake, okay? It looks like I added 4 to the left side of the equation. What did I add to the left side? What number? 3 times 4, which is what? 12. So it looks like what happened was it looks like I added 4, but I really added 3 times 4 to the left side of the equation. So if I add 3 times 4 to the left side of the equation, what must I add to the right? Same thing, 3 times 4. So I have to add 12, okay? Does everyone see that? I added 12 on the left side of the equation. I've got to add 12 on the right, okay? So this is a perfect square. This is 3 times what? X plus 2 squared, which is what we said it was going to have to be when we looked at that visual a moment ago. What's 12 minus 7? 5. So to solve this, x plus 2 squared equal 5/3. So taking the square root of both sides, so x equal -2 plus or minus square root of 5/3. Okay, that's my solution for x. So here the key is, anytime the number in front of x squared is not 1, you have to factor that number. Okay. Let's look at this example here. So what you see here, let me just repeat for the video. This is a parabola in standard form. Let's see what happens when we complete the square on this guy. Okay, so the first thing I need to do, so I've got f of x equal 2x squared minus 12x plus 7. Okay. So I want to factor a 2 from the first two terms. So this is 2 times what? X squared, what? Minus 6x. Right. And I'm just going to leave some space there. Okay. So is that the same thing? 2x squared minus 12x plus 7. That's all still the same. Now the reason I left this space here is I want to complete the square. What's half of that number? 3. What's the square of that number? 9. But I always just tend to write it as plus 3 squared. Okay. That looks like I just added what? 9. All right. But what did I really add? I really added 2 times 9. I added 18. Okay. If I've got this parabola and I just added 18 to it, what must I do to get it back to what it was? Here, I've got a pencil. Yeah, if I added 18 of these, what would I have to do to get it back to this original? Subtract 18. Okay, so minus 18. Okay. So all I did was factor the 2, and then if I complete the square, that means I've got to add 3 squared. What have I done by changing it? I've really added 2 times 3 squared, or 2 times 9, or 18. If I add 18 to this parabola, in order to keep from changing it, I'm subtracting 18. So now, what do we see? This is f of x equal 2. What's inside the parentheses now? X, not plus, minus 3 squared. Because that's x squared minus 6x plus 9. And what's 7 minus 18? Minus 11. So what does this look like? This looks like a parabola in what form? Vertex form. Okay. So remember, in vertex form we had f of x equal a, x minus h squared plus k. Okay. The vertex of this parabola was what? H. HK. So this is a parabola in vertex form, okay? And the vertex is HK. So the vertex here is 3 minus 11. Okay, so by completing the square, I took something from standard form and it went to vertex form. Okay, and that is it. There's just one more that you can convert for the end of the lesson there. Okay, all right, remember we do have a lesson tomorrow.